Okay, so
Yep,
let's
I
start.
think a lot of people are joining. Let's wait for 2-3 minutes, I think.
Okay,
Still people are joining.
so
Good afternoon, everyone, whoever is joining from India, and good morning, good evening, whoever joining from across the world. Yeah, some people started using the chat. That's a good thing. I'll be noticing the chat and feel free to question to the panelist and host. I'll go through it and definitely take some questions. So, yep, I think we should start, right? Uh, Today we're going to have a webinar, and we have quite a good number of panelists with us. So myself, I'm Kunal Das. I joined Cast AI, I think just 2 weeks back, seeing the product, and I love the product, so I thought let's join this company. And today I'll be just moderating. I'll not talk about much. I'll just take your question and ask the panelist. And Abhishek is one of the finest DevOps enthusiast person I have seen. So he's collaborating with us, and we have Rinku Bangar from Exilian, and we have Gaurang from CastAI. So if you guys want to introduce yourself, Abhishek, if you want to go first.
Yeah, thanks a lot. Um, First of all, so nice to see a lot of people during this time. It's just before lunch in India, quite early in Europe, late night in US, but yeah, still a lot of people are here. Um, so my name is Abhishek. Before to full-time content creation, I was working for Red Hat as a principal software engineer. I led OpenShift GitOps team, where I got to work with a lot of customers at scale. And I'm also an open source enthusiast. I maintain Argo CD operator and I donated Argo rollouts manager to Argo Proj Labs. But I started slowly shifting my focus to content creation. Probably you can call me a full-time content creator now. I have a YouTube channel with close to 500K subscribers, where I mostly focus on content related to DevOps, cloud, SRE, and also MLOps, AIOps, and AI these days. Yeah, this is pretty much about me. You can follow me on YouTube, and I'm quite active on LinkedIn. I'm super excited for this webinar.
Yeah, I think people who are joining, everyone knows about you. So, Rinku, if you want to go ahead and add 2 cents of your.
Yeah, sure. Great to meet everyone today. My name is Rinku. I lead the cloud solutions over at Excellion, where we've primarily focused on FinOps. I've been working with the Cast team for best part now of 2 years, and we've had a great journey with them. So if there are any partners on the call, definitely connect with the Cast team. We're working with them in almost every single continent now. Coming from Southeast Asia to LATAM to Europe to the US, and we have only positive feedback from all of our clients that are working with the guys at Cast.
Yep, Gaurang, you want to take it?
yep. Okay, good afternoon, everyone. Myself Gaurang. I've been in this industry for almost 13 plus years, doing from startup to product-led companies. Very vast experience from blockchain to DevOps to data scientist. But yeah, today I'm part of Cast AI as a Sprint CTO, being managing a pack for almost 3 years. And nice to meet you all.
Yeah, so today we're gonna be talking about the automation playbook, and Gaurang is gonna take us to the journey. And chat, if you are having any question to Abhishek, to Rinku, to Gaurang, feel free to ask in the chat. I'll take the question to them. And I think Gaurang, you can go ahead and explain what basically Cast AI does, and then go ahead and explain the slide decks.
Yep. So, yeah, Cast AI is a Kubernetes automation platform. Uh, we basically have developed our own intelligent autoscaler, which takes the decision in terms of what type of machines you want and what size of machines you want. And everything is human free. It's completely automated. Every decision has been taken based on the cluster environment, based on the workload behavior, and the scaling up, scaling down events naturally happening in the clusters. So that itself, this take the decision in terms of what infra you want and everything. And we optimize infra using AI, and that has resulted in a lot of savings. And that's why we basically are automation plus optimization platform. So today's agenda was to show the power of automation, but before that, we actually did a study in terms of what does the data look like in the real world, right? So the background is basically CastAI customers connect to CastAI, and then when they connect the cluster, we capture the state of the cluster, right? So that is before CastAI started managing infra. So we collected all the data points, and we wanted to study that what we understand from this data, from this structure, right? So we developed a methodology. In this data set, we covered almost 2,100 odd companies and their clusters, multiple types of clusters. We kept a 50 CPU plus benchmark so that the cluster which has well above than 50 CPU, it means the clusters are actually doing something in the real world. Anything below 50 CPU, we discarded those data points, right? And the time period for this study was around Jan to December last year, and across all the cloud providers, right? So there are a lot of insights we actually understood from this study, and that's where we want to share the data point with you. But before that, we want to do one poll. So it's a very first insight based on our first insight. So we want to take a poll that what is happening. So poll is live. The question is, what is your estimated CPU utilization in your current KTS cluster? There are 4 options we would like to answer. And let's see what's the opinion coming out from the real world.
Guys, the whole presentation would be interactive. Lot more poll quizzes will be going to come, and we are going to send some swags to whoever answers fast, and the correct answer, of course. So stay tuned for that. And there are multiple prizes from vest to jackets to airport also. So feel free to answer.
Yeah, and please select the option, because winners are from the options, right? So please do the poll. Yeah, messaging is good, but yeah, poll is also important. Okay. So let me know when the poll is closes, then I'll go to the real answer. Yes, poll is closed. We captured. Do we have the results? Yep. Okay, so 8% have given an option of less than 20%, and the majority is going from 50 to 60%, which is good. Okay. So let me
Abhishek,
give it.
what do you think about this result? Only 8% is thinking is less than 20%.
Yeah, I mean, I think they'll be quite surprised looking at the real numbers because, even while I was working at Red Hat, I used to deal with OpenShift and traditional banking applications or even large scale product, especially in the retail space. So what I've noticed is, they prioritize application. They want their application to be available and reliable. So they often ignore about the cluster utilization at the first point. But once their application is stable, they just go back and see that, oh, okay, we have underutilized resources to the core. So yeah, I think they'll be very surprised looking at the real numbers, but I want to see it from Gaurang as well.
Yeah. Same Abhishek, same opinion that when I was managing infra in my previous company, we never took seriously the utilization. Yeah. So allocation was the most serious topic for us, if the allocation is being done properly or not. And we burn a lot of money, definitely, yes. Right. And that's how we got to know that, we have to focus on the utilization. Okay, so here's the answer. The answer is 10% of your total CPU allocation, which means what is the provision in the system. is totally utilized, which means that let's suppose you have 100 CPUs in your cluster in total, you are only utilizing 10%. When I say utilization, it's a real utilization, not the requested one. I think people always confuse between the requested provision and utilize, right? Utilize is when you basically run a command called top in your computer, and then the screen comes, and then you see the real utilization. Right? So let's suppose you have 15 core or 16 core, whatever core machines you have it, uh, and that utilization in terms of what is the processor look like. Right? Memory, we are good. Memory, we are 23 utilization, but CPU is 10%. There are three terms I'm going to use it. Right? One is CPU utilization, which is the real utilization, actually your workload are using for. Second in Kubernetes is basically the requested CPU, which your application request for, and that has to be there in the system because that's how it works. And third is the provision CPU, which you are paying for, right? So we are talking difference between the provision versus the utilization. Right? Requested, we are not talking about, right? So what we have, right, 10% is actually being used versus provision. What is the impact of this? 10 times, right? So you're paying 10 times more than what you are using as of now. So that is the real world example. And that's where we come into the system and solve this problem with automation, because automation is the key. It works 24/7 for you, always checks and monitors, and that's how we solve the problem. Humanly, it's possible, but it's very, very tedious to do. And nobody can do 24/7 work, right? You have to have two people doing 3 shifts to cover 24 people, like 24 hours. Right? Whereas the AI agent can do it much easily, right? So this is a real world example. We captured one of the workload. Uh, the data is basically from Jan to Feb, almost 1 month data. Here, the blue line, what you see is the actual CPU requested, right? So once you request the CPU, it has to be there in the system because the scheduler always look for the requested CPU. Based on that, only it provisions, right? The real usage is the green line. We can see that's happening. And that's the over provisioning is between both of them. The real usage is somewhere around 0.0001 or something like that.
Sorry to
So
interrupt
once
you,
you,
Gaurang.
yep.
This is just a nice message someone posted. Balaji, this like he mentioned, like I also answered it 20 to 40%. However,
Mhm.
as I checked quickly, I see all my nodes are utilizing less than 10% CPU. So just wanted to point that out.
Yeah,
Yeah.
that's the true story. Means the data, we have the link for the study. Probably will share it at the end of the call, but that link has much more insights than what we're covering today, right? So the whole benchmark study, we're gonna share it soon. Yeah. So nice to know. I think it's the real one. Right? Okay. So this is what we're looking at, the workload autoscaler. We enable the automation. It is being, optimizing it based on your real usage, which is the green one. It cut down the CPU from 0.3 to 0.00414, right? And we are still above than your green, you can see, right? But that's how the real would look like. We have reduced the automation actually has reduced the infra almost by 10 times, right? Uh, there are a lot of questions in the chat, probably, Kunal, you are taking care of. Just stop me
Yeah.
if anything interesting you
No, no,
find.
I'm noting them down. I'll ask at the correct time. Uh,
Okay.
One question that is coming right now is some particular time the CPU utilization will go more than 90%. So he's talking about the
Hmm.
under provision. We'll
Yeah,
talk about
I
that,
think
Ravi.
I'll cover that. No issues.
Yeah, yeah, I'll
Very, very
cover.
good questions, right? Uh,
Yeah, yeah. I'm
in
noting all the
Kubernetes world,
questions down, so I'll
yep,
ask at the right time.
yeah, this is very interesting one. Let me cover that question since you asked already. So CPU and memory, right? In Kubernetes world, CPU is a compressible resource, which means if you supply a little bit less, the job will still work, but it will take a little bit more time, right? Memory is not compressible resource. If you supply less, you'll get overkills, right? So since the CPU is compressible resource, you supply less, it will take a little bit extra time, but it will do its job. So let's think that, sometimes in a day, probably small microsecond times, if you're touching 90-95%, which is all fine, but you have to look at the average number of CPU what you're utilizing in the system. And based on that, you have to configure that. Right? Otherwise, you always go for max and end up losing. 90% of the time, you're over provisioning the system. Only some 10% of time only you're doing actual utilization of your value. So you have to take the balance. And that's what the engine does. It actually does the balancing part. Okay. So I'm gonna go next. Cool. Okay. So once we did this study, there's one more data point we understood, right? That some of the applications were artificially under provision, right? When I say artificially under provision means they have been defined less by developer, but in the real world, it has been actually much more, right? So 6% of the containers actually used higher memory than the requested one. We investigated why it is like this, and turned out to be that it can lead to an out of memory issues, or it can lead to a performance bottleneck issue, right? Then next, what we did, we actually enable automation for that again. This was the example, real world example. So the real usage was somewhere here, and the memory basically was somewhere here. So they defined 2 GB memory, but the real usage was hovering around 3 to 4. Right. So what we did, the automation basically kicked in and increased the memory. Once we increased the memory, it started using more, right? And you see at the very end, it has settled down somewhere there, here. The impact of this was almost 2x the TPS. So the application was artificially bottlenecked and not being set properly as per the real usage. And people was or developer was thinking, okay, it's the performance, the maximum performance they can get from this application is, let's suppose, 100 transaction per second only. Once you enable the automation, they got to know, okay, we have to do it. We are now getting 2x with the same amount of code and no optimization needed, right? It was an artificial block because, again, developer somewhere sitting down, thought that this is my right value. They provision it. The infra guy basically mostly took it as it is and maintained the infra and deployed. And that's how this situation came. So this is very rare. Most of the cases we see over provisioning, but sometimes only 6% time we have seen under provisioning also. Right? What is your feedback, Abhishek, for this? Anything you have seen? Something like that? You're on mute. Yeah.
Abhishek, you're on mute.
Sorry, I definitely second what you mentioned. Just wanted to add about the spike at a point. Probably, also one more important thing to consider is the lower environments. A lot of times you get the insights from the lower environment, but people uh, do not care much about the lower environments as much they do for the prod environment. So if you have a proper setup where you get the metrics of your lower environment, probably that would also help you tackle this situation better. But otherwise, I completely agree with what Gaurav mentioned.
And Abhishek,
Awesome.
Rinku, I can ask the same question to both of you. Like, what percentage of your career or workload that you have managed have you seen the correct provisioning of resources happening across? So now this solution we are talking about, like before that, like we used to do manually request and limit. Like you have worked across multiple enterprise and multiple scale and sizes. Like what have you seen like in real world? How many times have you seen the okay, this is the correctly provisioned thing?
I mean, I can start with that. I would say extremely less because uh, just going back to the previous one that I talked about, always customers have their, or always people want to have their application available and running first. So, infra comes second for most of people, unfortunately. I would strongly consider it should shift left, where people should also consider infra while they are building and while they are deploying the applications. But to answer the question, the awareness that I've seen is very, very less. They end up realizing very late that, oh, okay, we are spending too much on the cloud, or we are spending too much on Kubernetes. Now that everything is burnt, let's go back and retrospect and let's see how we can improve.
Yep.
Yeah, just to
Rinku, you want to add
Agree.
something? Yeah.
yeah, it's probably more. So we obviously we sell to multiple into different continents. We see different trends in different places, but we're seeing a heavy over provision across the board, right? People and it takes something. So for most people, they see it as business as usual. They don't necessarily see it as a wastage until we do an exercise like this, and then we see actually what's reported. Until these things are done, we've had clients who we've done assessments, and they've effectively told us to hold off from sharing this to any of their seniors because the wastage is so high, and they want to then try and manage that, right? So we've seen all different types of
Um,
scenario.
yeah, I can vouch for that, Rinku. That's the most problematic situation when you are dealing with the client.
Yeah.
That you have to save the client also.
Yeah, that's so. Yeah, we've seen the very bad, and we see some clients who manage it very well, but the ones who are managing it very well, there is a lot of overhead for them to manage it, right? So these are teams that have a very, very large DevOps team, engineering team. Um, but yeah, so yeah, I think yeah, like adding to what Abhishek said, I think a large proportion of these are definitely over provisioned.
So it's actually not a human problem. It's a more of a process problem, I would say, right? Because in in a big company, for example, the infra team is basically responsible for the application liveness, right? And the developer team is responsible for the application runningness, right? So it should be running fine. So where the intelligence of the infra in terms of utilization is with the infra team, but the decision in making is done by the developer team, right? So that's where the big gap is, and there are
Yeah.
too much back and forth between the teams, right? And that's why they end up having a lot of mistakes. And I always say this, that if you provision 2x or 5x or study 10x, you'll never see a problem of bottleneck or infra issue. Means your 10x guys, there will be no downtime in the system. But when you are it's 1x, then you can see the downtime, right? But you have to find the balance. That's the main task, right? You cannot spend 100K for 10K actual utilization.
And Gaurang, someone is asking Santosh Garole, like, can you elaborate how exactly it's very less as you are mentioning 10%? Like,
Mm.
uh,
So
so that's the question. So basically,
again,
it's a data, right?
it's a data set, right? The data set what we have used for study, again, I said it covers a vast amount of clusters, almost 2,000 plus customers, and we manage almost a million plus CPUs. So it has all the data points, including that, right? So it's an outcome of the study. You may be at 40, 50, you have managed well. Thumbs up. You are the 10% of the entire infra, but it's the overall study what we have got.
Yep, yep.
Awesome.
And can I take some more questions if we have time? There are a lot of
Yeah, yeah.
questions. What if we use node autoscaling and bin packing strategies to maximize node CPU uses without overcommitting? How will cast
Yes.
AI play a role in that case?
So, yes, node auto scaling is one, definitely yes. It's important. Bin packing can help you, maybe increase your utilization a little bit more. Then I think the third solution, what you do is workload right size, right? So all three has to be automated. Then only you can achieve somewhere down the line, like 60, 70% utilization. Otherwise, you'll end up having somewhere around 20 to 30% that bracket. That's my experience from past couple, 4, 5 years of what I'm doing. Yes. Yeah.
And another guy
Kunal.
asked last question. I'll quickly check. Arif Sheikh has asked, like, using less than 20% doesn't mean aren't resources are getting wasted. Can't we have something like auto scaling based on the uses in the scenario?
Yeah, that's what is the coverage, right? Definitely, yes. You should have
Yeah.
auto scaling based on usage only. And that is the intelligence you have to build in the system.
Okay, we'll
Yeah,
take some more questions. Feel free to ask. And Abhishek, what? Yeah,
Yep.
what do you want
yeah.
to
I
Abhishek.
say?
mean, I have a general question because a lot of people uh, might have not used Cast AI. So the question is, like, let's say if I have a DevOps engineering team and I constantly look at the metrics. Let's say we have set up observability, and I constantly look at the node metrics of Kubernetes. Probably I get the pod metrics. How difficult or how different is it from a DevOps engineer manually looking at metrics and timely auto scaling it versus Cast AI? Like, do you have any
Yes.
information like how efficient is Cast AI?
Yeah. So I'm going to cover this probably with more example in going further, but let me answer you very short, very quick. Uh, Manually, you can do it. Yes, I'm not denying that point. But the question is, the variability in the system is too high. Let's suppose in a start of the day or start of the month, you manage and manually configure it based on whatever that you see in your Grafana dashboards, right? Will that sustain for continuously 24 hours? That's the question, right? Will that sustain for 3 months? That's another question, right? Especially in the case of the spot nodes, right? The prices keep on changing. So if you check price today, are you going to guarantee that the prices are going to have the same in next months or maybe next year, next quarter? That's the challenges we have, and that's why the automation helps you optimize 24 by 7, right?
Got it.
You are in the cloud world. That let's understand it. We are in the cloud world. We pay rent per hour.
Hmm.
So let's suppose 5 hours also you have extra provision in the system, you wasted that money. So you need a
Makes sense.
system which basically works for you 24 by 7, cut down whenever not needed, add optimized when needed, and take the intelligent decision in terms of which is the cheapest or most optimized resource for me. So that is the decision you need 24 by 7. Manually possible. You have, as I said earlier, let's suppose for one cluster or two cluster, you have to keep two people shift
Hmm.
or 8 hours or maybe six people, you need 24 by 7 monitoring and keep on doing those changes or manually or some automation. But it's tough to do. That's the question. Right?
Yeah, yeah,
Any
makes sense.
automation can be done manually. It's just that it's so tough to do it.
Perfect.
Okay, cool. So let's move on. We'll take more questions later part of the session. Yeah. So okay, I'm here. And I think we are at the right end, right? We were discussing manual versus automation, but they are a trade-off for being manual, right? Because of the habits, right? Habits are hard to change. And let me give you an insight, right? So let's take an example. So I have a trend in terms of spot prices. So there are three machines which are M7A, M5A, and M6A. There are three machines and their price trends over the year, right? I only captured for first 2 months. By looking at the trend, which are the machines we're going to pick? Or maybe Abhishek, let me ask you this question. Which machines you're going to pick for your decisions or for your clusters?
I mean, definitely looking at the trend, I would go for something inexpensive. Probably
So this
M6A.
is the price, yeah.
Yeah,
Yeah.
probably
So
M6A.
M6A is the green one, yeah.
Yeah,
But M5A is also not a bad choice if I look at the
definitely.
data of
Definitely,
Feb
yeah.
month, right? So
Yeah,
it's an M6A, M5A, for month A and B, right?
yeah.
Definitely not M7A, right? So let me take you the real example. This is the trend, right? This is the price trend across the year. So, like, Abhishek, you're lucky you pick M6A, you because of the trend, yeah, and you pick the right machine. But let's
Yeah.
suppose I picked M5A because the price looks same for me, right? I end up losing at the year end a lot of money,
Hmm.
especially from June onwards, right? Before June, it was all fine. So that's why the habits are tough, right? If we take a decision based on February month only, we would have ended up either M5A or M6A. But as the time goes, you see M6A turn out to be a better machine. And it's all static data, right? Tomorrow it could be
Hmm.
M5A. It depends on the
Hmm.
trend of your region, why, what the people are liking, what the developers are picking most of the machines, right? It all depends on that. Or maybe this year it is M7A is the cheapest. We never know, right? The question is, are we able to do it automatically? pick the right machine at the right time, which is the cheapest one, and follow it. Right? Human lead is
Got it.
possible. It's possible. It's difficult. That's what I'm saying. Right? And that's why the automation comes and solve the problem for us and do it decisions automatically. Okay. Now we have a quiz time. I think this is okay. Yeah, this we already covered.
Shall I take some questions? If
Yeah.
you guys are okay.
Maybe.
So Saurav asks, like, how is it different from Carpenter? How AI is popular, but I want to know what's the actual benefit of it over Carpenter. Same question asked by Avinash, like Carpenter versus Casta if I'm using eCase.
Yeah. So Carpenter is a very great tool. Let me be very honest, right? It's a great tool. It does the great job. Okay. The the question again, I think the last graph was enough to answer that decision, right? If you are in the Carpenter space, right, you have to define the EC2 YAML file. And you have to define, once you define the file in which you define the families of the machine, then are they appropriate machines or not, right?
Yeah.
For the latest example, in my recent experience, there's a new series came X8
Yeah.
in the AWS, which is the cheapest now. Latest, 2 days back only. I had this incident, right? Cast A started picking X8 because it was the cheapest. But how would the developer know who's managing Carpenter that X8 is down in the system, right? That's the question. So that's the main difference, right, between Cast and Carpenter.
Yep. So I think that answers, like, a lot of people are asking similar question. I think that answers for most of them. Uh,
Also, there
so
is one interesting question. Sorry, this is
yeah, go ahead.
from Fahami Karim. So Fahami
Mhm.
asks like, oh, sorry, this is from Diman. How safe is it to connect Cast AI to our company's Kubernetes cluster? Because we provide, like, do we provide the entire information to Cast AI, or how exactly is it
No, no.
safe?
So Cast AI agents only need Kubernetes metadata. When I say Kubernetes metadata, it's basically machine related data, like what type of node you're using, what type of workload you have, what is the CPU memory utilization of this workload. It's all machine data. The agents are restricted to pick any logs data, any sensitive information in terms of secrets, config maps. So all the permissions are by default set that it cannot read this information. The scripts are open. You can go and check. Documents are open. You can go and check. So agent doesn't have permission, and we don't need it actually. We just need the data to take the decision. So Kubernetes metadata, which tells us that where the pod needs space or more capacity, we just provision it. It's just that we take the decision in terms of which is the best and cheapest, and that's how we provision in the system. Okay. Kunal, do you have any question?
Yeah, I'll ask. So some guy is asking, like Pranay is asking, so when the automation process kicks in, like if something goes under provision over permission, when the cast agent kicks in, like will it disrupt the existing workload running in the cluster? Like will it
Mhm.
kill it? How is it works? He wants to know.
Okay, so in Kubernetes world, the way it happens, you have, let's suppose you have infra, all you create more pods, either HPA or deploy new applications, right? So it creates more pod. The more pods basically ask for capacity. The scheduler checks for it, right? And if the capacity is available, scheduler will go and provision it, right? If the capacity is not there, the scheduler put that particular pod into the pending state. Once it is the pending state, that time autoscalers basically look at the capacity demand. What is the requirement, right, in the CPU and memory? Then checks the entire cloud providers machines. There are 600 odd machines available. From that, it understands which are the set of machines which are right fit for it and the perfect size, and then create the capacity. There are a lot of steps, looks like, but the decision making happens in microseconds. So we have to be very fast and agile to do not disturb and stop it. So all this step process happen in the background to get you the machine. But when you pod become in the pending state, within microseconds, we basically create the capacity. So we have the autoscaler is so fast, and that's why we also require a lot of compute. And that's why we have a SaaS solution. We don't have an in-place cluster solution, because that solution will take a lot of compute in your infra. So that's why we created a SaaS company where basically the decision making happens in the SaaS. Heavy compute is part of our forte, our infra, not your infra, and you just have the benefit of optimization.
Uh, just to add in between the question, like whoever is answering correctly, will reach out to them for the vest, and we'll ship it to their address. And some people are asking, I'll just summarize the question, similar question people are asking, maybe any one of you can answer. So many organizations are using open cost, kube cost, etc. solution to monitor the Kubernetes cost and etc. Right now, Cast is also offering kind of similar. One part of Cast is definitely the monitoring dashboard aspect of it. Like when to decide to switch to some more detail oriented solution like Cast, rather than using something like a very trivial, a very rudimentary solutions like Kubecost or OpenCost. So
Yeah,
if you guys can answer, yeah.
I'll answer the last one. Probably I'll start with Abhishek, uh,
Yeah.
because Abhishek is the open source guy.
No, I mean, definitely. See, one thing that I really appreciate coming from, the FinOps Foundation or the projects like OpenCost, they are definitely helping to increase the awareness because it's an open source solution. You can definitely go out, give it a try. But end of the day, if you're talking about MNCs, I think you need a managed solution where you need someone who can take care of your entire Kubernetes clusters. They look at it and probably they help you. Okay, through the intelligent solution that Castair provides. This is the node tier that probably you can go for, or this is exactly where you're wasting your resources. Uh, Probably you can take this solution and improve your uh, efficiency, cost efficiency. So what I would say personally, those projects are definitely good. They are helping increase the awareness, but Cast AI has matured and it's a far better solution when compared to those things. Yeah.
So it's the
Yeah,
proactive
so
base,
let
right?
me.
It's just monitoring and then kicking in and then proactively like provisioning resources. That's the added part, right? Not only just monitoring
Yeah,
that keep cost offers. Yeah, Gaurang. And
I'd second Abhishek's thought, right? That's how it start. In start of your journey or start of any startup, they want to go for open source, right? And probably they can do it open source, 2 cluster, 3 cluster, or maximum 5 cluster. The workload is very less till the time, and they have other priorities. So the first priority becomes the infra management. But when you start to grow, right, the cluster size start to grow, the number of clusters started to grow, it become more and more tedious. When your cluster is, let's suppose, say less than 50 CPU, manually doing it, not a problem. You can do it. But when you grow between 500, 600, and thousands, we have clusters with 40,000 CPUs also today, right? It makes it it's unmanageable cluster because there are 40 teams working on that cluster. There are 300 plus odd applications running on the cluster. How will you do it manually, right? And the question is, it is not the same in the different infra. Let's suppose your stage infra have 300 applications. Their utilization pattern is different than the dev infra, and the prod infra is totally different. How to get every cluster in place with, let's suppose, say 10 to 15 people DevOps team, right? Lot of bandwidth goes only in this task, whereas they have a lot of other automation tools like CI/CD pipelines. Make sure GitOps is working fine. Make sure you have Terraform on in place. Everything, the push of developments and releases goes smooth. Make sure the checks and balances and the security is there. So DevOps team is not only constrained to doing infra management. They have a lot of different responsibilities, and they have to take the balance. And that's where basically they think, okay, can we offload this infra management thing to Cast, and let them solve this problem, because they can do it better than us. Even though we do it, let's suppose they can do 20, 30, 40% more better than us. So let them do it. Like we focus on our cluster. So that is what the real story we have, come up with most of the customers. By the way, Cast gives 2 cluster free of cost. Uh, if you want to use Cast initially, we have a free tier where we give around 2 clusters free tier, free of cost. If you are in that zone, probably use it, no issues. We do not charge over there, right? And our monitoring is also free of cost. So you don't need cube cost for that also to manage. Because if you have cube cost, you have to put it in your infra, you have to pay for the memory, pay for the compute. Whereas we are free, we do not charge it. That is our contribution to the open source. That's what we think. Our CTO always says, what is our contribution to open source? And that's what we think that we can contribute to the community, that, give at least some free tier, probably free monitoring and 2 or 3 clusters free of cost. So that's what our contribution is.
Another question, like I can answer this. Like Komapalli and Satyanarayan is asking, can you show us a demo to better understand how Casta is doing automation for CPU utilization? So demo is available.
Definitely.
The read-only part is free. You can connect your cluster, not a problem. If you want to see hands-on demo, you can come to KubeCon, our booth. Abhishek would be there at the after party, and we have launched the API Hero program. So if you get certified with CastAI, then you will get an automated invite, and you can meet Abhishek also. And yeah, so that's the answer. And
Okay.
Dhiman also asked another question, like that's very good question. Like, how does the company decide to choose CastAI? Before bringing CastAI into the organization, we need to clearly explain to the management why we need it, what problem does it solve, and why aren't the existing solution helping us reduce the cost effectively. These are key questions that must be addressed to justify its adaptations.
Yeah. So the best part is Cast AI automate your infra and optimize. Uh, the automation basically bring down the cost of the infra, and our charge model is something like, we just charge some minimum stuff from what we save. So technically, if you bring Cast to the system, we will be net positive, right? We're going to pay you back in terms of your cloud infra bill reduction. So Cast will not be charged. It come as a free or self-pay solution. So even though you want to try it, that's the most important thing, right? We're gonna be self-paying ourselves in your infra, right? Okay, let's continue. I think we have a lot of to cover.
Sure.
Great questions. Yeah. Okay, so the next insight what I have is same for GPU, right? GPU is the most costliest, SKU in cloud. So how to find best and cheapest GPU, especially in the spot world, because on demand we know, right? It's a fixed cost, everybody knows it. But if I ask you to run an ML job, or if your infra team or maybe a CEO or CTO ask you to run your ML processing jobs, and run it as cheap as possible, what is the answer to you, right? That's what the answer we are trying to find here. So basic information, there are 3 types of GPU we are covering. The prices in the study we covered, like A100, V100, and H100. Same availabilities across the region is there. For Azure, same GPU we covered for GCP, and same GPU we covered for AWS. All of 3, and you can see the percentage of availability of the GPUs availability in the spot market, right? So that is the price and trend. But what we are trying to see is, again, the question is where we can run it the cheapest possible, right? So what we did basically is we drew down the prices, price difference from on demand to spot across all the months. Jan, we took one period, Jan, then Feb to May, June, July, August, September, and then following, right? So these are the months, and we took all the prices. We looked at the best place to run the workloads. When I say best, means is the most efficient running, right? So most cost-effective way of running this. And the regions which we covered is these 2. And if in January, if you ask me that what is the best place to run GPU and the cheapest place to run GPU, it was US West 2A. In the next 4 months, it was around US West 2B. Then if I move to July, it becomes Northeast 1A, maybe it's a Tokyo. And then we have Seoul, which is Korea. Then we are back again to US and following forth, right? These are the regions where you basically find the cheapest availability. Okay, let me give you the price difference. This is the price difference. So if I ask you to run a GPU, probably you're running on demand, let's suppose, right? And if you enable the automation, right, we will make sure that we run this 10 times cheaper by provisioning into the US 2A, because that is the cheapest, right? And automation knows it, right? Manually is not difficult. In the second time range, it was 7.7 times cheaper, right? And so on and so forth. That is the impact of the automation if you leverage the automation very well, right? So, and the availability also you can see highest in the system, right? So that's the trend we look like. And this is the real data. I think the same data I've shown you for the compute. This is the real data for GPU. Again, GPU is the most costliest SKU, so we have to be very, very cautious to run it, and that's how we basically solve it. So again, the best place to run the AI workload, its availability of the GPU varies. You can run it with spot 2x to 7x cheaper compared to the on-demand price, right? Cool. So I think the whole ingredient of solving this is automation. Again, we discussed vastly that can we do it manually or not. I said yes, means we can do it. It's vastly very difficult to achieve it, right? And that's why the automation is the key ingredient. Let me take an example of how well automation works. And this is what the example is. You see the trend here. Let me explain the graph. The blue line is what the provision line is, right, which you are paying for. The blue shadow is the requested CPUs, and the green one is basically your average utilization. And once you enable the automation, you see how well it basically following your requested curve versus automation, right? Any questions as of now, Kunal? Or let me just finish, explain this graph more detail here, and then we'll probably open up the question because I think we only have 10 minutes left.
Sure.
Cool. So the line which I showed you, the graph which I showed you earlier was after the effect, but how it looked like before is here. Again, this is a graph which one of our customer we captured. The yellow line is their actual utilization, and this is the customer facing example. So in the early morning, the usage was very low. In the start of the day, the usage start increasing. It peaks somewhere around 10, 11 a.m., right? And then in the lunch, it goes down, and then again picks it, and then the night it goes down, right? So this is yellow line is basically a curve, and the CPU request. The blue is basically the normal autoscaler, right? And it actually in the morning when you start asking for more capacity, it actually adds much faster. No issues with that. It adds, right? But when you are stop using it, right, in the afternoon and the night, it basically take a very laggy decision and take slowly taking it off, right? Ultimately, you're coming into the right shape, but it wastes a lot of time and resources in between, right? Let me take you the result of automation. Right? This is the result of the automation where we basically closely follow the gap of your real world requirement. The best part is the automation, the autoscaler, the agents run automatically 24/7. So every 15 seconds to 30 seconds, they takes and thinks whether I need to optimize this cluster now, right? Is there any node empty in the system? Let me delete it. Is there anything which can be moved around and free up in the resource? Let me do it, right? And that's how basically it goes and optimize 24/7. In the night, very end, you will see both line very close, right? But it takes a lot of time. The difference between the left graph and the right graph is a 40% cost advantage. That's the impact, right? And again, we can do it manually, but probably in the daytime, right? 11 o'clock, we checked the cluster and we optimized it. We turn off some machines and did it, right? But can you do this every hour? Let me increase the granularity every 30 minutes. Again, increase the granularity every minute. Again, increase the granularity every 15 seconds. Cast at every 15 seconds. So that is the granularity at level we work. And that's how we're able to get it much closer to than this one. And that's how we save a lot of cost. And we end up saving around 40 to 50% bare minimum any client. Right? Okay, so that was the impact of autoscaler. Let me give you another example, right? How you can take intelligent decision in terms of machine selection. And your machine selection decision depends on the type of workload, right? And in the left side, you can see a very big cluster, almost 400 CPU. They have configured a lot of node pools to optimize it, better compact it, right? And you can see we have mostly 3 node groups. One is this type, other is this type, and this other is this type. Because in the cloud provider, you can only configure 1 or 2 type of machines in one node pool. So it becomes an homogeneous setup. So what developers try to do, okay, let me create multiple node groups. When they create multiple node groups, they create multiple resource islands, which means they cannot share between. So application from one node group cannot share the resource from the application in other node group. So they end up wasting a lot of resources. Your applications are heterogeneous. When I say heterogeneous, it means that they have a different CPU and memory demands, which your node pools are not, or node configures are, node groups are not. They are homogeneous. Like homogeneous means you're blanketly adding one type of machines again on top of it, right? So you try to, in Kubernetes world, you try to retrofit a heterogeneous setup, which is your workloads, to your homogeneous setup, which is your machines, and try to retrofit and try to see then, can I optimize this system? It's not possible because heterogeneous setup require heterogeneous configuration, not homogeneous configuration. And in the cloud world, you cannot do it because that's how the node groups have been defined, and that's how cloud provider has given the functionality to you, right? We break this myth. We create a heterogeneous group for heterogeneous workload, right? So it means that we're going to create a multiple type of machines, multiple size of machines, multiple processors of machine in the same Kubernetes node group. Right? How we do it, that's a different question, but that's how we do it. And that's how we solve this problem. And in the right side, you see we are able to get a different machines in a single node group, right? And that's how the impact of the CPU memory is very high. Okay, I think I jumped it. Let me explain more detail. You see, we have 392 CPUs and 421 GB of RAM. Whereas in new setup, you see CPU is lesser, but memory is high. So maybe your aggregated memory requirement was more than CPU, and that's how we basically optimize it much better. The cost impact is following. You have earlier, the customer was paying around $4,300. Now they're paying around $1,400. The impact is almost 67% reduction. And this is the intelligent decision making, right? What type of machine you need for what type of workload, and that's how we basically save a lot of cost, right? So earlier example was better decision making, quick decision making in terms of removing capacity. The second decision was better decision making in terms of machine selection. And the third impact of the automation is better price distribution of spot. I think we have discussed a lot about spot, right? Spot variability in terms of EC2 machine, in terms of GPU. Again, automation can help you pick the cheapest one. And for this customer, they were already on spot earlier. They moved to us. And I gave the example, like 40%, the same cluster example. Just picking the right machines, we are able to save around 40% more than that. Right? I think that's it. That's it for today. We have Q&A. Let's take some questions. Kunal, you're on mute.
Yeah, sorry. Arun is asking, what if the workload is fluctuating or being so aggressive will not be a problem for sudden burst?
No, the sudden burst, again, the way we architect customers are, we make sure that we categorize the machine applications in 3 priority category, like P0, P1, P2, P3. P0 machines are expected to have almost 100% SLA, right? So we make sure that we have enough capacity provision So shredded burst is basically been conquered, right? And on top of it, we also discuss with them what is your SLA looking like, right? What is the minimum benchmark you're looking like? If you're looking at, as let's suppose, 1000 TPS as a minimum benchmark, we make sure that much capacity is there in the system, right? Even though we are not using it. So it all depends on planning and plotting. We decide with customer what is the requirement, what is the benchmark you're looking like, and based on that, we set the policies, and that's how we basically proceed further. So
So
sudden burst,
basically,
definitely
it's
yes,
fully
can be answered.
customizable. So basically, it's fully
Yes.
customizable.
Yeah,
So as per
it's fully
anyone
customizable.
needs, they can like we can make
Yeah,
it as per their wish. Yeah, yeah, yeah. Makes
yes, yes.
sense.
We sometimes cover peak also. Let's suppose they set P100. P100 means the 7 days last peak was being set as a requested CP. So that is also possible.
Yeah. One guy asked a question to everyone. Maybe Rinku, I think, would be the best person to answer this. So, as Gaurang was saying, that regional pricing across for GPU across different region are massively different. Sometimes it's 10x savings. So, how do you think, like, have you used that feature of Cast AI to get savings? Like, naturally, we select the lowest one that is possible, but across the year, the pricing changes, right? So, how do you react to that?
I would so on my what our clients would do is do it so it depends on where, again, location of clients, how quick they need to get the delivery, how and kind of what cost savings they're having. We tend to find clients are usually dictated by local compliance of where they need to be, and that's how they would then pick and choose that. But pricing does vary. I wouldn't see yeah, I guess in terms of choosing that, I think it's usually client preference, and they set that up. You have the two clients. Your clients who want to try and save the most, and you have clients who want to kind of restrict what they're doing and how they're working.
Makes sense. Harish Reddy is asking a question like, will it affect the quantity of DevOps engineers?
Uh, as per my experience, no, because there always a more work to do. It's just that once they have cast, they open up the other pipelines or the projects which expedite that work. So it helps actually. That's what my experience is. As of now, I've seen it impacts on DevOps engineer because there are a lot of projects always in pipeline.
Yep, yep.
I mean, actually, what I realize is that this actually opens up a new area altogether, because if you look at cost optimization traditionally, DevOps engineers were quite restricted. Even the knowledge is quite restricted because as a human, you can only look at certain things, like what even Gaurang was mentioning before. So you only look at certain metrics, you look at it for a certain period of time. But adding solutions like Cast AI to your ecosystem, one, it definitely opens up new opportunity because now you need another person to look at Cast AI, to set up Cast AI, and also it gives you a lot of insights. So you are taking those insights as a DevOps engineer and you are setting up it, configuring it. So what I feel is that not reducing the effort, but actually it's going to increase the effort for good. The good side is your organization is going to benefit with cost.
Yep. There are almost like 160 questions. After I answered 30, 40, still 160 are left. So we may not be
No
able to
issues.
cover everyone.
Yeah.
Probably we can
That
answer them later on. No
Yeah,
issues.
definitely reach out
Yeah.
to us for that. And the quiz winner will announce that definitely, and we'll ship the prizes to their address, like whoever wins the quiz. And definitely reach out to any of us, Gaurang, Abhishek, me, Rinku, and visit cast.ai site. You can connect a cluster. 2 cluster is free, as Gaurang was mentioning, and you can get the monitoring, read-only security recommendation. Everything is free of cost. So try out that. If you have a dev cluster, connect it and check how it works. So you can gradually move it to production. So yeah, I think we are on time. I don't want to take any more questions. I'll try to answer, and reach out to us if you have any critical question. We'll try to answer as fast as possible. So yeah,
Yep.
Abhishek, you wanna say something on the end? Gaurang, Rinku.
Yeah, first of all, I
Yeah.
would like to thank the entire panel for for this wonderful session. It's really good to see some real numbers because in the world of AI we get to read a lot of things, but getting the real numbers from customers is very, very rare. Thanks, Gaurang, for collecting those data sets and presenting them here. And also I see a lot of interest amongst audience about cast AI. So I think we should do these kind of sessions more often, which also provides basic education on uh, costing, Kubernetes, various resources that Kubernetes offers and all. So yeah, looking forward for many such things. And finally, thanks for having me here as well.
Rinku, you wanna go ahead and just to mention in between, like if you connect your cluster, check the cloud budget and check the security, etc. There's a chance like we'll pick up winners, and there's a chance to win AirPods Pro 2. So give that a shot also. Yeah, Rinku, over to you.
Sorry, it was over to me. Sorry, the bit of a cut out there. Yeah, so look, so I'm assuming that was handing over to me. All right, Connell?
Yeah. So we're
Yeah,
just kind of concluding.
yeah,
So if
no,
you want to
sorry.
add something.
Yeah, no, thank you for everyone for joining. As mentioned before, if you have a chance and you have got you've got the time, I would just highly suggest doing connecting the clusters, getting the visibility of that dashboard, seeing what kind of savings you could potentially that are available to you, having a play around with the toolkit as well that's available, and getting your, I guess, the hands dirty with what of the platform. So we tend to see this as a first step for our clients and then move on to the next stages. So yeah, please go ahead and see look forward to seeing everyone at KubeCon as well. We'll be working with the guys at Cast on the stage as well as the after party.
Yeah, the after party is again I'm mentioning it's on after KubeCon on 7th of August. Abhishek will be there, and we'll be there of course. So if you're coming to KubeCon, just try to complete the API certification. You'll get an automated invite there. So yeah, I think that's it. Gaurang, if you want to add something before we just cut the call.
No, thank you so much for all of you for giving us time. Uh, we share the insight to everyone. Again, we are available in KubeCon. If you want to connect to us, probably connect us. Our team will reach out. Uh, if you want to reach out, I have shared my email. Kunal also shared his email. You can reach out to our emails for any questions. Happy to connect you again. Yes, there's a question that do a demo. We typically do one-on-one demos. We probably can reach out for demos if you want. And thank you so much for your time. Yeah,
Yeah, thank you everyone. Have a nice day.
thank you guys.
Thank you. Bye.